In this video, I'll show you how to solve optimization problems in calculus. This will serve as part 5 in the series. The steps to solving optimization problems as discussed in previous videos is written below. The question in this video reads, a factory needs to run a pipeline across a 1 kilometer wide river to a point that is also 2 kilometers east of its factory. It costs $5 million per kilometer of pipeline built under the river and $3 million per kilometer of pipeline built on land. In order to minimize costs, how far to the east of the company's factory should the pipeline be when it crosses out of the river? Let's start off by illustrating this. This dot represents the factory, and it's separated by a river that is 1 kilometer wide. The pipeline has to be 2 kilometers east of this factory. So if it was directly down, that would be 0 kilometers east, so it has to be somewhere here. And it has to be a combination of both a pipeline under the water and a pipeline that is on the land. So it's going to look something like this, where that represents the pipeline, and we know that it's going to be 1 kilometer. And also, we know that the distance from here to here will be 2. We don't know the distance from here to here, so we're going to call that x. So what we can do at this stage is first find out the length of this line. And we can do that quite easily by using the Pythagorean's theorem. That is a right triangle. So therefore, if we use the Pythagorean theorem, a squared plus b squared is equal to c squared. A will serve as your first leg, and 1 to the power of 2 is 1. B will serve as your x squared, and c is what we're looking for, our hypotenuse. So therefore, c is equal to the square root of 1 plus x squared. So we know the length from here to here. However, we don't know the length from here to here. So what we can do is say that the length on land is equal to 2 minus x. We can now create a formula that combines both of these lengths and their costs. The cost for the river is 5 million times the length of c, the square root of 1 plus x squared. Furthermore, the cost also includes what's on land, so it's going to be plus 3 times 2 minus x. Now that we found our formula, we can find the critical numbers, and using those critical numbers, we can figure out whether that number represents a maximum or minimum. Let's start off by finding the derivative of the first term. The first term is 5 times 1 plus x squared to the power of half. This and this mean the same thing. And we're going to do the chain rule. We're going to bring this down, rewrite that, and find the derivative of 1 plus x squared. Let me demonstrate. 5 times half, rewrite this, 1 plus x squared, subtract that by 1, negative half, and then find the derivative of 1 plus x squared, which is equal to 2x. Combining all of this together gives us 5 times 2x, this and this, over 2 times the following, 1 plus x squared. Next, we're going to find the derivative of this term, but first we need to expand. If we expand this, we end up with the following, 6 minus 3x. And if we take the power rule to both of these terms, we end up with simply negative 3. So let's write this all down. C prime, our cost, is equal to 10x over 2 times 1 plus x squared square rooted, minus, as we stated earlier, 3. The next thing we'll do is set c is equal to 0 to find our critical numbers, and using those critical numbers, we can confirm whether the number is a maximum or a minimum. So we're going to set c is equal to 0. And remember, 10 over 2 is equal to 5, and this one cancels out. So 5x is equal to the square root of 1 plus x squared minus 3. We're going to solve for x now, and that shouldn't be hard. We're going to bring this 3 over, becomes positive. We're going to multiply both sides by that, which gives us 3 times the square root of 1 plus x squared. And we have 5x on the right side. The next step is to divide both sides by 3. If we do that, we end up with 5x over 3. On the right side, 1 plus x squared, square rooted. We're going to square both sides, giving us 25x squared over 9, 1 plus x squared. Now multiply both sides by 9. This cancels out. We end up on the left side with 9 plus 9x squared is equal to 25x squared. We're going to bring this over. We end up with 25x squared minus 9x squared is equal to 9. And I'm doing this really quickly, I understand. These two subtracted give us 16x squared. 9 over 16 is equal to x squared. And we're going to square root both sides, and we finally get 2x values. 9 over 16 square rooted, and x2 is equal to negative 9 over 16 square rooted. So, which of these two do we choose? Of course, we can't choose the negative value because it doesn't make sense in context to our question. How can you have a negative distance in this particular case? So, we're going to use this variant. And of course, I'm going to use the simpler of this variant, which is equal to the square root of 9, which is 3, and the square root of 16, which is 4. I'm going to use 3 over 4. And now what I have to do is prove that 3 over 4 will minimize the costs. And the way we do that is we take the limit of 3 over 4 with the original equation. Now, if you recall, the original equation looked like this. C is equal to 5 times the square root of 1. So we're going to take the limit as x approaches 3 over 4. And if we do that, we end up with a cost of 10 million. Now you also need to take the limit at its extremities. We know that it's going to be a maximum of 2 kilometers away. So we can also take C at x is equal to 2, which gives us approximately 11.2 mil. And of course, you want to take it at its extremity. So we know that it has to be between 0 and 2. So you can also try at x is equal to 0 just to be sure. C at x is equal to 0 gives us 11 million. So therefore, we know for sure that a distance of 3 over 4, which is 0.75 kilometers, is the distance that will minimize the cost for this factory. If you found this tutorial helpful, please support our channel by subscribing or by liking this video. If you have any further questions, you may visit our website at biology-forums.com. We are an online service for students seeking free homework help. See you soon.